Hi dear friends, good morning to all. Myself Fybsc, a system professor, Department of Chemistry, Gokhale Education Society's Arts, Commerce and Science College, Java, District Palghar. Dear friends, in the previous part of the video of this online lecture series, we particularly discussed about the syllabus of Fybsc in the subject of chemistry paper 2 for the first semester. Dear friends, after the review of syllabus for the first semester in chemistry paper 2, you might be aware that particularly there are 3 units in each semester in each subject or in each paper in the subject chemistry. Unit first based upon the physical chemistry, which are entitled as chemical kinetics and the liquid state, while the unit number 2 is based upon the inorganic chemistry, which is entitled as comparative chemistry of main group elements, and the last unit means the unit number 3 is based upon the organic chemistry, which is entitled as stereochemistry. Dear friends, already I told you I am going to teach you the unit number 1 and the unit number 3 means the topics entitled as chemical kinetics, liquid state and the stereochemistry. So dear friends, in this part of the video we are going to actually study or we are going to actually start the syllabus based upon the unit number 1 entitled as chemical kinetics. Dear friends, this topic chemical kinetics is much more familiar to you all because it is already included in your 11th and the 12th subject. As now you have taken the admission in the first year BSc. So before discussing this chemical kinetics, we would like to revise this chemical kinetics based upon the syllabus of your 11th and the 12th. Before discussing the chemical kinetics or the need of chemical kinetics, it is necessary for us to know the importance of chemical kinetics or why we are going to study the chemical kinetics. If you are remember about the topics which was included in your 11th and the 12th subject, then there was topic called as chemical thermodynamics. In the chemical thermodynamics, there are different terminologies like state function, Gibbs free energy, Helmholtz energy, like this. And this state function indicates that the function which depends upon the initial and the final state of the system is called as a state function. Dear friends, whenever we will study the chemical reaction with the help of thermodynamics, the progress of chemical reaction can be studied with the thermodynamic function, then it will be called as the chemical thermodynamic. The main important use of chemical thermodynamic is that from the concept of chemical thermodynamic we are able to predict whether the reaction is possible or not, but at the same time we are not able to predict the mechanism of reaction, pathway of reaction, rate of the chemical reaction cannot be studied with the branch of chemical thermodynamics. It only tells that whether the reaction is possible or not, yes or no. And hence it is necessary to study the pathway of reaction, mechanism of reaction if you want to explain the rate of reaction. So rate of reaction at any instant can be explained with the help of branch of the chemistry or the physical chemistry, then that branch is called as chemical kinetics. So this is the purpose why we are going to study about the chemical kinetics, because there are some drawbacks, there are some limitations of chemical thermodynamics, and these drawbacks or the limitations of the failure of the chemical thermodynamic is overcome by means of another branch of the chemistry called as chemical kinetics. So here, based upon the same, whenever you want to explain the definition of chemical kinetics, then it's very important, very easy. It is simply defined as the branch of physical chemistry which deals with the study of rate of reaction, mechanism or pathway of reaction, and the various factors which are responsible to affect the rate of reaction. So in the chemical kinetics, particularly, we are going to study about, or it includes particularly the three part. One is the rate of reaction, mechanism or the pathway of reaction, and the factors affecting a rate of reaction. Then the branch is called as chemical kinetics. So it's very simple definition to define the chemical kinetics is that the branch of physical chemistry which deals with the study of rate of reaction, mechanism of reaction, and the factors affecting rate of reaction. Dear friends, this chemical reaction can be classified into various types based upon the criteria. If we will consider the physical condition of the substances taking part in the chemical reaction, then the reaction can be classified as homogeneous and the heterogeneous reaction. Here, in order to define the homogeneous and the heterogeneous reaction, if all the substances taking part in the chemical reaction, if all the substances taking part in the reaction are in the same phase, either solid, liquid or gas, but if all the substances take part in the chemical reaction are present in the same phase, then the reaction is called as homogeneous reaction. Instead of this, if the substances taking part in the reaction are present in more than one phase, it means that if one substance present in the solid form, solid phase, then the another will be present in the liquid phase. It means that the substances taking part in the reaction are present in more than one phase, then the chemical reaction or the reaction is called as heterogeneous reaction. Definitely it's very simple to define the type of chemical reaction based upon the physical condition or the physical state of the substances take part in the chemical reaction. As already I told you, in the chemical kinetics particularly we are going to study about the rate of reaction, mechanism of reaction, and this mechanism of reaction or the pathway of reaction will decide the rate of reaction also. And also we are going to talk about the factors affecting this rate of reaction. So how can we define the rate of reaction? How can we explain the rate of reaction? That is also the important thing here. Here, in order to define the rate of reaction, here I try to consider one simple reaction in which A is the reactant that reacts and it gives the formation of product, and B is the product here. So there are two spaces, one is the reactant, another one is the product. Capital A is the reactant, capital B is the product here. Dear friends, if you will see here the progress of reaction with the time, then you will come to that. So this is a reactant. So this is what? This is the reactant A. This line indicates the reactant A, and this line indicates the product, that is suppose here B. Okay. If we will plot the graph of concentration versus time for any particular reaction, then we will come to that as the time increases, as the time proceeds, the concentration of the reactant A here goes on decreasing. It's very important because the reactant will react and it will be converted into product. But at the same time, as the time increases, as the reaction proceeds, the concentration of the product formed in this case goes on increases with the increasing time. It means that as the reaction proceeds, as the time increases, in any chemical reaction, the concentration of the reactant A or the concentration of reactant always decreases, while the concentration of the product always increases. This is the normal case, this is the normal observation in any chemical reaction. And simply here also, if we will consider both the concentration, here concentration of reactant A and the concentration of the product, definitely the concentration of this reactant A will decrease and the concentration of the product B goes on increasing with the increasing time. And with this change in the concentration of reactant and the concentration of the product, with the change in time, with the increase in time, we are able to define the rate of reaction. So what happens here? As the time increases, the concentration of reactant decreases while the concentration of the product, while the time increases, the concentration of the reactant decreases while the concentration of the product increases. And based upon the same, the rate of reaction or the rate of chemical reaction simply defined as change in concentration of any reactant or any product per unit time is called as rate of reaction, or it is also called as the increase in concentration of product to the change in time or per unit time is also called as rate of reaction, or it is sometimes it is also defined as the decrease in concentration of reactant per unit time or with change in time is also called as rate of reaction. So with respect to this, if we will plot the graph of concentration versus time, then definitely we will get such a nature of the graphs for the concentration of reactant A and the concentration of the product B. And if we will plot if we will calculate the slope of this, then the slope of this line will be change in concentration of the product. Here it is positive sign. Why it has positive sign we will discuss later on. Divided by change in time dt, and the slope of this line will be minus negative sign dCA, change in concentration of reactant A to the change in time. Okay, so with this change in concentration of the reactant to the change in time or change in concentration of product to the change in time, we are able to define the rate of reaction. Here it means that we are also able to define the rate of reaction in terms of concentration of reactant as well as concentration of the product. Here already we tried to define here the rate of reaction is simply the change in concentration of any reactant or any product per unit time or with change in time is called as rate of reaction. And for this simple chemical reaction in which A is the reactant get converted into product B, the rate of reaction simply defined as minus dCA by dt. This minus dCA by dt is the decrease in concentration of this is the decrease in the concentration of what? This is the decrease in the concentration of reactant. So this is very important, that why it has negative sign, but this C suffix A, it is the concentration of the reactant and it has negative sign because the concentration of the reactant decreases with the increasing time or with the time. That's why here it has negative sign. So minus dCA by dt is the decrease in concentration with change in time or with increase in time. Minus dCA means the decrease in concentration of reactant with the change in time dt. Again the same can be also defined with the help of concentration of product, or the rate of reaction can be also defined in terms of concentration of product, and that is simply rate of reaction will be also equal to plus dCA by dt. Here this C suffix B, this is what? This is the concentration. This is the concentration of what? This is the concentration of product. So this C suffix B, this is the concentration of product, and it has the positive sign. This positive sign indicates that the concentration of the product increases with the increasing time or with increase in time. That's why it has the positive sign. And this plus dCB by dt indicates that the increase in concentration of product with the change in time. So it also, or it is also called as the rate of reaction. So here remember one thing is that we are able to define the rate of reaction in terms of concentration of reactant also and in terms of concentration of product also. But in terms of reactant, it is simply defined as decreasing concentration of reactant to the change in time, and in terms of concentration of product, it is simply defined as the increase in concentration of product to the change in time. Or in simple way, we can define the rate of chemical reaction as the change in concentration of any reactant or product per unit time is also called as rate of reaction. So here I hope you got a clear idea that we can define the rate of reaction with by various ways. Again, this rate of reaction also depends upon the various factors, because in the chemical kinetics not only the rate of reaction but also the factors affecting rate of reactions are also studied, and that's why we should consider the factors that on which the rate of reaction depends. And then it is observed that the rate of reaction depends upon the various factors, out of which the first factor is the temperature. And it is observed that here the rate of reaction depends upon the temperature, and here it is simply observed that as the temperature increases, the rate of reaction also increases. It means that rate of reaction and the temperature both are directly proportional. It means that as temperature increases, rate of reaction also increases. And it is also observed that if the temperature of the reaction is increased by 10 degrees Celsius, then the rate of reaction is also shows the increase by means of 2 to 3 times. So here this is the relation, a quantitative relation, how much rate of reaction can be increased with the change in rate of reaction with the increase in temperature of the reaction. The another factor on which rate of reaction is concentration of reactant, and it is also observed that the rate of reaction at any instant is found to be depends upon the concentration of reactant, or is found to be directly proportional to the concentration of reactant. Hence we can conclude that as at the start of reaction the concentration of reactant is greater, and at the end of reaction the concentration of reactant will be smaller. Hence the rate of any chemical reaction initially is greater, and this rate of reaction decreases with the increase in time, or as the reaction proceeds the rate of reaction decreases with the decrease in concentration of reactant. Again, the another factor on which the rate of reaction depends, then that factor is simply the presence of catalyst. If in any chemical reaction, or if in any chemical reaction the catalyst is present, then it can changes the rate of reaction. Particularly the catalyst is the species which alters the rate of reaction, which alters in the sense it may increase or it may decrease the rate of reaction, but in most of the cases catalyst increases the rate of reaction, and hence it is observed that whenever the catalyst is present in any chemical reaction, the rate of reaction also increases. The fourth factor, another factor on which the rate of reaction depends, is called as the particle size of the reactor molecule, and generally it is observed that rate of any chemical reaction generally increases with the increase in surface area of the reactor molecule, and this surface area can be increased with decreasing particle size. It means that if smaller is the particle size, then greater will be the surface area. Definitely it is the part of imagination, and I think you can imagine very well. And hence if smaller is the particle size, the greater will be a surface area, and hence greater will be the rate of reaction. It means that if the particles are present in granular form and the same particles are present in the powder form, then always or then the rate of reaction will be always greater in the powdered form, because in the powdered form the particle size will be very smaller as compared to the granular form. And that's why in many cases the reactant molecules or the reactant first converted into powder, and then the chemical reaction should be started, and because we will get the more rate of reaction, so reaction will be completed in smaller time. Another factor on which the rate of reaction depends, and it is called as the concentration of product. Here it is also observed that the rate of reaction also depends, or the rate of reaction may depends on the concentration of product if and only if this product of the chemical reaction is works as the catalyst or is responsible to catalyze the reaction, then concentration of the product increases the rate of reaction. Or if the concentration of the product is responsible to form the reactant again, in that case also the rate of reaction will depend upon the concentration of the product, because as it reforms the concentration, it reforms the reactant, so definitely the concentration of the reactant will change, and as the concentration of the reactant changes, the rate of reaction will also change. And that's why in on this rate of reaction depends upon the concentration of the product only in these two cases. In first case, if this product catalyze the reaction, and in the second case, if the product is responsible for the formation of reactant again, then and then the rate of reaction depends upon the concentration of the product. So dear friends, today I think you got a clear idea about what is chemical kinetics, what is rate of reaction, how can we define the rate of reaction in terms of concentration of the reactant as well as concentration of the product, and how we can define the rate of reaction in equation form. In equation form in the sense change in concentration of reactant or change in concentration of product to the change in time dt. At the same time, I think you got a clear idea about what are the factors which will decide the rate of reaction. These are particularly temperature, concentration of the reactant, catalyst or the presence of the catalyst. Again, another is the particle size of the reactant molecules, and the last that we discussed is the simply concentration of the product. So dear friends, today we try to discuss this the concept in the study of chemical kinetics in this online lecture. In the next part of the video, we will discuss about the particularly how the rate of reaction can be calculated and what is the relationship between the rate of reaction and the concentration of reactant at any time with the help of law of mass action in terms of rate law. So dear friends, we will again resume in the next part of the video to discuss the next another concept in the chemical kinetics. So thank you very much. Thank you once again to listen. Thank you.